All right, so let's start with the parent function again. So f of x equals x squared. So we just explored what happens when we add and subtract both outside of this operator and also inside of the operator, right? So now let's try, let's see what happens when we multiply. And so if I start with f of x equals x squared like we have, and then the next one I do 3 times x squared, what do you think is going to happen? And if you guessed, that's not it. If you guessed that it would stretch vertically, you're right. So what happens is it actually pulls up. So it's like it's anchored here, like you stick a nail right here and then you pull it up. And so it's kind of like elastic. It's gonna look like it looks like it's kind of pushed in, it's narrowed, but it actually pulls up. Okay. And so so let's see, this is f of x equals 3x squared. Okay, so actually it's a vertical stretch is what happens. So vertical stretch, and it's by a factor of 3. Okay. All right. Now let's say we did 1/3. I didn't graph this here, but if we did 1/3, let's say I did f of x equals 1/3 x squared. Instead of a vertical stretch, it would be a vertical shrink. So it would actually be something like this. Okay. And that's probably not drawn exactly right to scale, but it'd be a vertical shrink. Or compression, sometimes people will say, by a factor of 3. Okay. All right, so what do you think if we multiply 3 inside the operator, if we did it inside the square? So if we do it like this, what do you think is going to happen? And you probably guessed it. What's going to happen is it's going to be a horizontal compression. So it's actually just like everything was backwards on the inside and we added or subtracted, positive move left, negative moves right. So if I multiply by 3, it's going to be horizontal, but it's actually going to shrink instead of expand. Okay, so it got pushed in, squeezed in this way. Okay, whereas this one got stretched out, right? Okay, so that's going to be a horizontal shrink or compression by a factor of and it's actually 1/3. Okay. Now, if I did the other way, if I said f of x and then I put 1/3 x inside the parentheses squared, then it would be a horizontal stretch. So it would actually come out like this. Right? Kind of like this one did before, remember? So they're very similar, like a vertical stretch looks similar to a horizontal compression, right? Or horizontal shrink. And a vertical shrink looks like a horizontal stretch. This would be by a factor of 3. Okay. And I forgot this one would be by a factor of 1/3. All right. Okay, so hopefully this is making sense. Let me know if you have any questions. Let me show you one more. All right, so we're going to start with the same one, f of x equals x squared. So the parent function for a quadratic. And now what we're going to do is we're going to see what happens when we change signs. Okay, so what I'm going to do is I'm going to put a negative out front there. Okay, notice there are no parentheses. It's just out front. Okay, so when it's outside of the operator, usually what happens, is it's a vertical change, and that's the same thing here. What's going to happen is it's a vertical flip, okay? So if you do negative x squared, then it's going to be a vertical flip, okay? Or sometimes people might say a reflection across the x-axis, right? Because this is the line of reflection, right? It's flipping over that line. All right. Now let's see, what if we put the negative on the inside? What do you think is going to happen? That's right, it's going to be a horizontal one, right? Where'd my graph go? There it is. All right, so you can see what happens is it starts out here, right? And it flips. So this side now goes on this side, and what was on that side before now goes on this side, right? So it actually flips right on top of itself because it's symmetrical. So if I say f of x equals negative x squared, negative is inside the parentheses, then it's going to be a horizontal flip, or a reflection, across the y-axis, right? Because this is the line of reflection now. All right, so that's what negatives do. All right, so when we add or subtract, it's going to be those are called translations. That means they just shift. It keeps the same shape of the graph, but it just moves it left or right or up or down. If we multiply, those are going to be stretches or compressions. Sometimes they're called shrinks or dilations, contractions. And then we have, if we change a sign, that causes a reflection, and that's a type of transformation or a flip. And so if the negative's outside, it's going to be a vertical flip. If the negative's inside, it's going to be a horizontal flip. So now that we know pair functions in these, we can just look at an equation, and we can say, okay, we know it's this shape, and then we know this is what happened to it, and so we can graph without having to plot all those points.